I'm sorry guys, I think I was making a mistake in here, but I already fixed that. That's why I cut the video. And we got here that is 3. This is multiplying x3 to the square minus 2x2 multiplying x3, okay? Then it's going to be plus x2 to the square. And all this part equals x3 to the square. Most likely what we gotta do right now is that I'm gonna show you this is the diagram, and it doesn't have any notes on there. Most likely what you gotta do is equal this equation to 0, because it's gonna be 2x3 minus 6. I'm sorry. It's minus 2x3 plus 6q x3 x2 all this square, and this equals to 0. Okay, basically this is what we got from this equation. So most likely I'm going to erase this one so we can have a little bit more space. Here it goes. Here it is. Now remember that we already got the value for x2. So what we're gonna do in this case is introduce this value on the equation. It still 2x3 plus 6q x3 minus 5.83, and this equals to 0. We gotta get this 2x3, most likely it's gonna be x3, the first one and the second one, okay? We gotta get these values, getting the x3. I'm just gonna get here the value that I have, and it's 13.80, and the second one is 3.70, okay? I'm going to, so in this case what we gotta do is pick the value that is bigger than this one, because in this case we're saying that this one is my first charge, this one is my second charge, and if we take this one, it's gonna be in this part, and it won't be possible because since this one is positive and this one negative, it's gonna be movement on the charges. So we want to put the charge under here, so it needs to be a bigger one, and we're gonna take this one, okay? So I hope you guys are understanding this part of the problem, because most likely what we did in this space, it was to get the x3. So we add the value from the x2 to this one, so we can get at the end the x3, and we can choose any of those so we can get at the end the value, okay? I'm gonna erase this, and remember that at the first diagram here we got these triangles, these are triangles with angles, which is alpha and theta. What we gotta do in this case for alpha and theta is get the tangent of alpha, and this one is gonna be minus 3 and minus 5, because remember, you guys remember that these ones are the coordinates for the diagram that we have over here. Remember that the first charge is on minus 3 and on minus 5, okay? So most likely we're gonna get now alpha, and then we're gonna get theta. Alpha equals 60. So perhaps since alpha equals 60, theta is gonna equal 30. And now we gotta get my A, which is most likely the value that we obtained at the beginning, okay? Which is, remember, it was 13.80. Now what we're gonna do is add these values. I hope you guys see my face. We're gonna add these values on my x and y equation. Okay, it's gonna be, first of all, we're gonna put my value A, which is 13.80. Okay, and since it's in x, we're gonna get the cosine of my angle that is over there. Remember that theta is 30 degrees. And then on y, we're gonna get the same 30.80 sine of 30. And give me 1 second so I can look for the value that we obtain over there. Okay, the value in this case is going to be 11.95, and the second value is going to be 6.9. Over here on the cell phone, I just got the results from all the steps that we got. I'm gonna repeat everything as fast for you guys. Remember, we got a diagram, we got first charge and second charge. We hope that the third charge could be in this space. So we get alpha and theta, and we get then x2 by the square from the coordinates to the square. Okay, so then we substitute this value on the first equation that we equal to 0, so we can get the 2x3 possibilities. We got to choose the bigger one because it's going to be bigger than this value. So most likely then we get the tangent from alpha, so we can get the angles on the diagram, and then we only put the angle theta on this one and on x and on j. Okay, so the coordinates for charge 3 is going to be 11.95 and 6.9. This is my last answer. Okay, thank you for watching.